Alright, so here's example question number 6 for probability. So this is about a game called Think a Number, as I would call it. So the rules are as follows. A person, which I would call the thinker, is chosen and is asked to think a natural number in the interval 1 to 36, both inclusive. The thinker then gave some clues about the number as demonstrated in the following questions. Then the others will have to guess a number that the thinker is thinking of, and multiple guesses are also allowed. So for part A, the thinker is assigned and he gave the following clues. So first, it is a two-digit number, and the sum of digits of that number is 7. So yeah, what is the probability of guessing the number correct the first time and wrong the first time but right the second time? Right. So let's just think about the possibilities about this number. So since it is a two-digit number and the sum of digits of that number is 7, the possibilities will be 16. That's also a possibility since it is a two-digit number and the sum of digits is 1 plus 6, which is 7. We also have 25. That's also a possibility. And finally 34. We can notice that 43 is invalid here since it is out of the interval that the number is allowed here. So therefore there are 3 possibilities for guessing this. And for part 1 of part A is pretty straightforward because let's just assume the answer is 25. So therefore the probability of guessing this number will be just, well, the number of possibilities of getting the right number, which is just 1 since there's only one correct answer, over the number of possibilities, which is 3. So the probability will be 1/3. Next, part 2. Well, although we kind of need to draw a probability tree diagram, but we can only just draw some of it. So let's say he answered wrong right here. I'll just write W for this. And this is about right. And then we can just connect the branches right here. Notice that since the probability of getting right for the first time is 1/3, the probability of getting it wrong the first time is 2/3. And then the probability of getting right will be, well, notice that since one choice has already taken, so let's assume it's 34, there's only 2 possibilities and only one right answer left. So the probability of getting it right will be 1/2. So therefore our probability for part 2 will be 2/3 times 1/2. That will be 1/3 yet again. Finally, for part B, another thinker is assigned and gave the following clues. It has exactly 3 positive factors and it also divides 72. Well, a number that has 3 positive factors is expressible as p squared, where p is a certain prime number. And we must also maintain this must be less than or equal to 36. So the possibilities of these numbers will be as follows: 2 squared or 4, 3 squared or 9, and finally 5 squared or 25. So yet again, there are 3 possibilities, or 3 possible numbers, given the first clue, of course. However, the fact that it also divides 72 leaves us with only 2, since 25 does not divide 72. So therefore, we have 2 possibilities left. What is the probability of getting the correct number the first time? Well, that's just pretty straightforward. So let's assume that it is 4. The probability of getting that correct number will be just, well, 1/2. And that's pretty simple. And let me just write that neatly. And that also ends this question and as well as this video.